Let's jump in. Thanks for everyone for joining our today's webinar, PFAS-free alternative that performs replacing 3M Novec HF chemistry without compromise. My name is Saroj Yadav, and I'm the product marketing director at Techspray and Chemtronics, which is a part of ITW Test and Measurement Division. We are thrilled to have you with us. And I see a lot of our distributors and reps and our end users are joining in. So welcome. Before we get started, here is the few housekeeping. The session will be around 45 to 50 minutes long. Today, the session will be the question and answer will be at the end of the presentation. So feel free to type in your question and answer during the presentation, and we will try to answer one of us, me and Paul, during the session or maybe end of the presentation. And we are recording this session, so we will be able to provide the videos and even the presentation after the webinar. So about the speaker, so I will be covering the regulatory and marketing piece in upcoming slides, and then later on, Paul Blair, who is our product technology director, is going to present for our chemistry side of applications. So let's jump into our agenda. Today's agenda is, I'll start with our introduction for Techspray, and then a little bit of recap what 3M has been doing, or what's the update on the PFAS chemistry on regulation side. And then we will jump on to the what type of replacement we have on Techspray, and what we can do with the PFAS-free chemistry for your application need. And then we will briefly talk about regulatory trades-off, and then we will summarize today's webinar and then jump on the question and answer. So briefly about Techspray. We are a brand of cleaners, coatings, and rework and repair, which is part of ITW Illinois Toolworks. And we do have a sister company called Chemtronics, which has very similar product. So everybody on this call, me and Paul, both handles Techspray and Chemtronics. So if you have questions regarding any of our brand, please feel free to reach out. However, today's seminar is focused on our Techspray products, just because our Novec replacement were first introduced under Techspray. However, there are some exceptions which are under Chemtronics as well. So Techspray actually started in 1968, and we have been really focused on the PCB industry for a long time. And that's something I want to stress, that we have experience in handling a lot of regulatory challenge over the time period. So we dealt with Freon CFC 138A discontinuation due to its impact on ozone layer, and it was used as a vapor degreaser, duster, and in aerosol, and as a cleaner, especially dry cleaning. Then we moved to HCFC 141B, which was also part of creating a hole in ozone layer, so that got discontinued. And then we moved to AK225, which was the next one that has gone as well. So while saying all these things, we're just trying to emphasize that we have been having so much experience as a company to go through all these processes, which we are currently going with the 3M Novec discontinuation. So as far as on the chemistry side, we have been blending our products using these not only 3M chemistry, but other suppliers like Commerce or Honeywell, and other substituents suppliers for HFEs. So we do blend our products based on the application, and we do provide all full service to our customer, and try to help our customer during any type of transition we could be facing towards. So being that said, we do have a full-fledged lab, which is part of Techspray and Chemtronics, and we do take a pride in terms of what we can do and what we have done for our product development for our other customer. And I wanted to even emphasize that not only we do have a lab in Kennesaw, Georgia, which is located at suburb of Atlanta, but we do have a global footprint. We do have a lab in China, Suzhou, which can be helpful for our end user who are looking for outside of US qualification. So we covered all areas, North America as well as in Europe. We do have a distribution center in Netherlands, which can do some sort of qualification process there as well. We can do small batch prototype and helpful analytical equipment. We can cover most of our testing in-house. For vapor degreasing type of application, which is our major goal for PCB type of critical cleaning, we generally focus on three things: cleanliness, effectiveness, and reproducibility. So we would want to get some parts with contamination from customer's line. We could get some parts from our end user and then run some testing based on what the requirements, and then do the material compatibility test with our lab. If there is a need for process optimization, that can be done or handled by our team. We do have a vapor degreaser, ultrasonic inline cleaner for our water-based cleaning application. And we do have a partnership with third-party labs. If we are not able to do it here, we can send our stuff outside of our lab to get things done, keep moving. So a little bit update on 3M. So they are still on their track to exist the PFAS chemistry, and they have been discontinuing a lot of their HFEs throughout this year. Major discontinuation happened around March 2025. Not only they discontinued a lot of their Novec chemistry, but they did also take away fluoropolymer, fluorinated fluids, and any kind of PFAS additives. This decision is part of 3M broader strategy to address the environmental and health concern by regulatory bodies. It is important to note that these are not like a mandate, like regulatory mandate or legal requirement. This is just like a proactive step or voluntary step by 3M to align with evolving regulations, stakeholder expectation, and public concern over PFAS. So I'm sure you have been trying to secure your supply chain since the discontinuation news came out from 3M by 2022. And we've been part of some of these discussion with you, or maybe our competitors might be, talking to you for securing those supply chain. There are a couple of things either you could have done or you have already doing it. Finding the chemical equivalent, or while working finding the chemical equivalent, you are trying to find a new replacement, which could be a future-proof process for your technology or your cleaning process. And that's where Techspray or Chemtronics could help you along with those next generation, either HFEs or next generation type of chemistry in critical applications, critical cleaning application. I wanted to touch base with you, like, what is these Novec solvents? I know a lot of our end user has been using these for years, and they have been part of their cleaning application for quite a while. The emphasis is based on what type of product actually can be part of these critical application. There has to be certain features that is required or that is needed for, especially for vapor degreasing application, thermal transfer fluid application, and carrier fluid as well. So for the straight Novec chemistry, which is part of 7100, 72, and 73, which is mostly widely used product portfolio from 3M Novec under critical vapor degreasing technology. These chemistry are neat solvent, neat HFE, which means that when you're trying to use as a rinsing reagent or under vapor degreaser, they are not going to change their any component or their molecular variation into the mix-up. While these are not a great cleaners or like a solvency, they doesn't have too much solvency by itself. When you blend these chemistry with trans or with alcohol, that's where you get a lot of cleaning during these blending composition. However, these blends should be azeotrope or near azeotrope. And what that means is once you are boiling your liquid, the vapor and the boiling phase should not change the composition of the liquid, so that it gives you a longer term safety during vapor degreasing process. So very mindful, like what you're using as an alternate, you should be able to see the chemistry and know if they are azeotrope or not, if it's a blended chemistry. These solvents has been used for as a carrier solvent for lubricant and adhesive, just because their inert nature and they're trying to get into the really tight surface areas of when you're using in a medical device manufacturing or in an aerospace industry. The next common thing is how do you define these PFAS? I'm sure you have heard a lot about these PFAS product or even the classes of PFAS over the 3 years, and we are just trying to make our end user or even our community who are using these chemistry, or even distributor or suppliers and even reps, just to making aware that these PFAS are not forever chemical. Everything is not considered as a forever chemical. The PFAS is an abbreviated terminology where P means polyfluoroalkyl or perfluoroalkyl. So polyfluoro means many fluorine atoms, or perfluoro is like if you're replacing fluorine atom by hydrogen. So that's where the name come from, and these are alkyl substance. So that's how PFAS is named as. The forever chemicals is actually based on what is the type of structure or what type of chemical integrity of these chemistry are. The press or the media who is calling these forever chemicals are not going after details of defining or even trying to see what structures of these PFAS are, or are they really truly forever chemical. So if you see the first structure on the right on top, it is actually one of the HFEs that is having CF2 moiety, and then the oxygen ether bond at the end, which provided flexibility around the chemical integration of this chemical. This is your Novec 7100, and the global warming potential of this is around 300. And the next structure below one is where all the fluorine atoms are fully saturated, and they have been global warming potential of this product itself is 1600. So you can see that how these different structure can vary on their global warming potential. The next one is HFO's structure, which has double bond saturated product into their into that structure moiety, and that helps it to degrade easily into the environment, and the global warming potential is around 1 or less than 1 for this type of HFO. So it's really important to see the structure of these, some of these PFAS, and what type of class we are dealing with. And the beauty about these PFAS is it's their properties. These carbon fluorine gives you really, lower surface tension. So that what that means is that it can, the solvent can go into the tighter areas. And if you blend with your cleaning agents like trans and ethanol, that makes it go into the spaces where it's harder to reach when you're doing critical cleaning. And even the high density is also helping to create that type of, interaction with the substrate and the soil that they are dealing with. And the next structure which I wanted to emphasize is the last PFOA's structure. You can see that has carboxylic acid in the end, and then there are other ones are sulfonic acid. Those are the really bad ones that are considered as a forever chemical, and we should not be using that. These are the ones which are persistent in the your bioaccumulative into the nature. So just to make sure, like, what we are seeing as a forever chemical, we know like what they are entitled. So the majority of the things are set up around PFOAs and PFOS type of chemistry. People might be targeting that NPBTC and PERC is another great chemicals, and they're single component. However, they're not very friendly with with the exposure that they give you to the workers when they're using it. Either they're very highly toxic, or their worker limitation to be used into a certain day period is shorter. So they are not the best chemical to be replaced with these PFAS. So just be mindful. And I know we're going to talk about the regulatory trade-off onto these chemicals in the later slide. Why it is so challenged with the PFAS regulations to define these regulation onto these PFAS around what we have known for years, or especially like when they were discovered in 1940. So this slide is just give you a brief overview what are the challenges we are facing in defining the PFAS. In 1940s and 2002, they have been like no regulation, or there's no check list onto these chemicals. And then later, the PFAS, the PFOAs and PFOS, they were found to be more persistent in the environment, and that has to be like more kind of changes that that made the EPA and US EPA or other regulatory body to look at them at differently. So in later 2002, where I try to make it as a whack-a-mole problem, where we try to understand more of these PFOS, that they are bioaccumulative and not really good for the environment as well as for your health benefits. So when there is like a lack of one thing, the scientists come up with another type of product or another type of class to replace the bad piece or bad PFAS. So just like to catch up with the alternatives, that analogy fits very well with the whack-a-mole problem. Then now this is the current situation, we are transitioning to where EPA is trying to define these PFAS. And in the next slide, we are talking about the PFAS under Section 8A7 for TSCA. So what US EPA did is that they have been trying to gather all the structure of related to these PFAS and put it together into their list of CAS number and the structural definition. So they try to tackle these with these three different definition. And if the structure is part of these three definition, then that considered to be PFAS and has to be reported under TSCA ruling. And this definition actually gives the researcher or the scientific community to come up with the new type of HFEs or carbon fluorinated bonds, which is not considered as a PFAS under this definition, to give them a new era of developing chemistry, which is PFAS-free, which is environmental friendly and can be easily degradable into the environment without having to worry about bioaccumulation. So US EPA has done quite a good work into defining that what should be considered as PFAS. And this is what we are trying to take this piece into development of our PFAS-free chemistry. So our ITW, Chemtronics and Techspray chemistry are based on this definition of TSCA 8A7. So be mindful of that. And that, take us to talk about what's happening with EU and other international bodies. So this brief slide actually gives you a little bit of what's going on with the EU regulation. And when EU came up with their PFAS definition, they actually talked about OECD definition, where anything which has carbon and fluorine board are considered as PFAS. So your TFA, which is the smallest molecule you can have under PFAS, is also part of PFAS, and that's actually a degradation process for a lot of PFAS. So it's not a best suited definition. Once they defined these PFAS early stages, EU actually take a step back and they are trying to understand what are the application these PFAS has been used and what are their alternates available. So they are looking these under as a derogation phase. So if you have an application which which is considered as a critical application, then they are applying for derogation, which can make these PFAS available for either 5 to 12 years. So they're just under data collection right now as US EPA is doing currently. The forever chemicals, which is PFOS and PFOAs, they are already under regulation, tighter regulation under EU. Similarly, the Asia and Latin America, they took actually a limited regulation stand on PFAS. They only limitation on the forever chemicals, not exactly the whole class of PFAS. Canada is also, more stricter regulation on PFOS and PFOAs, and they are also doing some regulatory studies. So today's we only focus on US EPA definition of PFAS for our Techspray and Chemtronics product. Next, this slide actually gives you a brief overview what has been in US EPA, what they are doing currently with regulation piece. It's a lot of material on this slide, so feel free to digest the information afterwards. This is just to showcase in one slide what's going on with the regulation side. So without divulging much more time on this, I'm going to proceed to the next one. And this is where we're going to talk about our chemistry option, and Paul will take over for the next slides and furthermore to talk about what the Techspray chemistry can do for your application. So when we came up with our strategy, how to tackle these 3M Novec Novec, going away from availability stand piece, we try to tackle it with 3 options that we can give it to our customer. The option 1 and 2 we have discussed in great lengths with our previous webinars, so feel free to consult those ones. They are available on our website. The option 1 and 2 only talk about the direct replacement with option 1, where you're not doing any validation process, and option 2 is like a midterm solution where you are using functional replacement and then to secure your supply chain. And the third is where the PFAS-free options comes in, and that's our current focus on today's webinar. So Paul, you want to take it along?
All right. Do I need to take over here? Can you hear me?
Yes.
Oh, cool. Great. We'll talk about the first option, the direct drop-in replacements. For a lot of users, this is going to be step 1. For many of those users, they might not want to even take another step. Given the regulatory landscape is not as threatening as it used to be, a lot of the drive to replace the PFAS is not as hard as it was, and they just need to secure a new supply chain of the existing product. This is the fastest, simplest, and easiest way to get over the Novec supply issues. But for a lot of other users, it's a bridge and helps them buy time to go with the next generation to move into the PFAS-free. Like I said, these are chemically identical. You cannot see any chemical difference between them. We have some analytical methods to demonstrate that for our end users, for our customers, or even their customers' customers. We're happy to provide that. Pictured here is the GC gas chromatograph showing that our 3710 is the same as the 7100. The gas chromatograph is a way of separating and identifying chemicals. If anybody wants to find out how a gas chromatograph works, I can give you a 101, and I have a chemist in the lab that could give you a graduate level course on how a GC works.
That will be the next webinar topics.
Yeah. And then, like I said, all of the Novec products you have listed there are available, or we provide now to the marketplace. The newest ones are the 649 and 1230. These are all available. But what we've done is we've taken those conventional Novec replacements and raised the bar a little bit and tried to add a little value. And so now we purify them and process them in an ISO 5 clean room to reduce the amount of cations, metals, in the solvent, and also really the amount of non-volatile residues. And of course, when you're doing all that, you're going to reduce the amount of particles as well. So what we've done is we've made an especially high purity, very clean version of these chemistries for use in really super critical applications like semiconductor supply issues, microelectronics, medical device manufacturing, and aerospace. When I say aerospace, things like very long life satellites and things like that, these things are extremely pure. And given the necessity, if you're an end user that wants or needs this degree of cleanliness, let's talk. We're working hard to expand this line. When I say, give a little more details here without going too far, when I say control tightly for metals, you can see we get less than 10 parts per billion is what we specify. However, we typically, on a production schedule, we can provide less than 2 parts per billion. Not something we want to promise 2 parts per billion every time, but we provide one much lower than the 10 so that we know that there's a degree of safety there. And even some of our smaller lab batches done in the clean room, we can get less than 1 part per billion. So this is we could get to really high degree of cleanliness. The metals we test, 40, go back up, 40 different metals. So it's really quite a bit. And sometimes when we're reporting our metals, we're not even, we report our actual plus the detection limit on the chemistries, on the compounds we can't even, or the cations we can't even find. So we're actually reporting at our detection limit, which is probably quite a bit higher than what our actual cleanliness is. Our cleanliness is actually quite a bit higher than the level that we report. So again, really ultra pure solvents. We're trying to help all of these industries go far beyond where they are right now. Sorry. Go to the next slide. Okay, so the second strategy that Saroj talked about was qualifying new chemistry, and it takes a little more effort. You know, in the first step where you're just trying to look for a different source for the identical molecule, it's about qualifying the supplier. It would be about qualifying us. Happy to work with you on that. But for qualifying new chemistry, you would have to. It would be important to evaluate how well it cleans and how compatible it is with your current process, how compatible it is with your materials. Again, our goal here is to maintain the current equipment, and get as close to your current processes as possible. But there's an option here sometimes with our chemistry that we've had, and by the way, we've had these chemistries on our line for quite a while. But sometimes we have opportunities to improve the cleaning performance, and in some cases lower the cost of some of these advantage or some of these Novec replacements. But again, it takes a little bit more effort, a little bit more effort to reduce the risk. We're very comfortable with these products, but we want you to be comfortable as well. So, we need to test compatibility with the materials and the process. We have, like I said, Saroj said, a lab here, and so we can do a lot of testing. We can test your parts contaminated with contaminants off your line, or if you like, you can just send us contaminants, and we can find similar parts here that we can contaminate and then clean and not just to check compatibility, but also kind of develop an optimal process to make sure that once we take it back to you, it really works. And then the third thing is possible. If we love it when customers visit and engineers and scientists and chemists work with us in the lab. Happy to come in and work with us in the lab to optimize the process, to evaluate what's going on. In some cases, the parts are very sensitive. We're not an ITAR facility, so when we work with DoD or military contractors or suppliers, they have to accompany the parts in. They work with us, and then they take the parts back out again. So, like I said, all of those are possible. Like I said, I love having people in the lab finding new things. Obviously, I love talking molecules. So, let's go to the next slide. Talk about more molecules. Okay, so these are our legacy products that we've had in the line for a while, and they're practical or functional Novec replacements, not chemical identical replacements. We talked about the chemically identical replacements in the first phase. This is the second one, where these are, like I said, functional drop-ins. The 3400 and the 3410, you can see down there in the cleaning strength, they get a plus, and so they're going to be a little bit stronger, cleaner than most of the Novec products. But the trade-off is in the next line is a plastic safe. Neither one of them are plastic safe, so there are all kind of trade-offs there. But again, and then we have the 3810 gentle cleaning. I dare say it's not like weak cleaning strength. It's just gentle cleaning, good for rinsing and so on. That would be the 3810. That is a fluorinated compound. These are all based on fluorinated compounds. And then the next one, the 3820, like we said before, has a little bit of alcohol in it for different cleaning strengths. So, like I said, these are things we formulated and can move on from there. Now, Novecs also function very well as thermal management fluids. We sell some thermal management fluid. We sell them to some customers as thermal management fluids. You can see our replacements are all about in line. The third column there, the third column of product, the 3710, 20, and 30, those are the 71, 72, and 7300 from chemical identical. And you can see that our offsets to the 3649, well, that's a chemical identical as well. But they're all kind of in line there between 1100 and 1250, 1260 in terms of specific heat capacity. And then you see our products are a little bit higher in terms of thermal conductivity. But the real critical difference you see here, we're identical in the first three operating range from about minus 108 to 49, minus 90 to 56. The last column over, you see that is a new product. That's why it's got an asterisk on it there. Precision B 3752. This is our countertype to Novec 7500, which has been a real challenge to replace. And you can see in that operating range why it's such a challenge to replace, because it's operating in a range from minus 109 C cryogenic all the way up to 107 C, which is over the boiling point of water. So really, really wide range there of 216 degrees C. However, this is a new product. We're very happy with it. And a little bit of the trade-off there is the specific heat capacity. It'll still absorb works very well, very stable, non-flammable, reasonable, kind of moderate global warming potential. It is a fluorinated compound, is a PFAS, but that's what we have in there. The 3810 and the are in line with the Novecs, and 352 are in line with the old Novecs. In the low hundreds, a little over 100 to low hundreds of global warming. But if you look over there to the Precision B 3649, that's really a very global warming friendly product with a global warming of down around 1. So that's right around where carbon dioxide is, which is can't get any lower really than that. So that's really our current lineup for a practical replacement, a functional replacement. So next thing we really spend a lot of time doing is, particularly in R&D, is we're always trying to look for the future, and try to steal that phrase from the word from the slang, future proof. How do you future proof your process? We want to try to get one that we know is going to last 10 years, and that can handle really any shock. Can handle regulatory shock, can handle supply issue shock, all of these things. So once we understand the cleaning performance, compatibility, and regulatory compliance, we can start to build a cleaning system. And so we really take two major routes to get around PFAS. And like I said, this is a little refresher on what repeat what Saroj said earlier. This is for people that want to have a PFAS-free product, either for regulatory products or regulatory considerations, or for public relations concern. They want to take away those fears, panic around it, and they want to avoid any kind of future regulatory restrictions on what they can use. And so there are two ways we can do this. There's the new chemistry with existing systems. It's a fluorinated compound with a trans to help clean. Could drop it into existing systems. This is the fastest, least risk, and lowest cost way to get into PFAS-free products. The other option would be significant capital investment in a new system, and you still have to qualify not just the system, but also the new chemistry. This would be water-based inline or batch cleaning, and maybe vacuum degreasing if you're not already using a vacuum degreaser now. So we got a 3900 Precision V 3900. This is a product that we began to develop during COVID to respond to supply chain interruptions and to really supply chain proof, I guess would be the term I try to grasp at, the product. The ingredients in this product are 100% made in the U.S., 100% domestic supply from the atoms on up to the product that we would deliver to you. Like I said, it's all U.S. based. This is PFAS-free by the EPA definition, and it's a very nearly perfect drop-in replace for 7100. It can also replace 72 and 7300, given some adjustments to the system and some adaptations, but still very good replacement and PFAS-free. It is a one-part ultra-stable product, doesn't change. As a heat transfer fluid, got some properties down there. It's got a very nice high specific heat capacity, higher than the Novex and the other fluorinated compounds we have. Higher, in many cases, much higher thermal conductivity as well. The only drawback is its operating range is a bit narrow. But you see the one in the middle, very low global warming. The global warming of only 8. So this is just a wonderful product to get away from all those high global warmers. We have 3910. This is a modification or an extension of the 3900 product, except it's diluted a bit with the trans-dichloroethylene. So it's a much stronger solvent. The 3900 is mainly for light cleaning and rinsing. But the lowest, so this does lower the global warming even below the 8. So this is almost equal to the trans, which is much less. Again, powerful cleaner for vapor degreasing or ultrasonic, and it's a very good replacement for the 71DE. And the DA is another extension onto that. Again, PFAS-free, another extension where alcohol is included, and to give it a little more cleaning strength. And again, another new product, looking for beta sites to test. So sign on up. Next one. So we're looking at ultra pure solvents. Again, we can provide this PFAS-free product in the same degree of cleanliness, less than 10 ppb metals, less than 1 ppm NVR. And then again, it also functions as a thermal transfer fluid. So very versatile and a very high degree of cleanliness. And then kind of moving on to the next 2 or maybe 3 alternatives as you run into. One is the water-based cleaning. We have 2 water-based cleaners. One is a legacy alkaline water-based cleaner, very environmentally friendly, high material compatibility, good basic alkaline cleaner for both inline and batch cleaners, easy to handle, easy to dispose of, just got to be neutralized. And again, it's like I said, just a good straight up inline and batch cleaner. The next product is one we really should talk about a little bit more. It takes away the necessity to neutralize when disposing. This is a really good cleaner. It's a neutral pH. We built this cleaning for inline and batch cleaning, but we built it from the bottom up. And so we said, well, what molecules would be great at cleaning and miscible or compatible with water? And so we kind of constructed the molecules on our heads, and then we said, okay, well, and then we went out and searched and tried to find similar molecules or close enough molecules. So this is really a unique product in that it's not built from the same kind of chemistries that everyone else is building the water-based cleaners from, which is basically mixing things that everybody knows about already. The beauty of this is it cleans some very difficult flux residues. Great flux paste from indium there, 8.9 HF and HF1, but the residue is quite a challenge to remove. These will handle all those residues in an inline cleaner, and we of course make the recommendations for the ITW EAE AquaStorm 200. It works just great. Good for those low standoffs and densely packed boards. And it leaves you with bright solder joints. You can run it as slow and as leave it in there as long as necessary, multiple passes. Even in some cases, aged fluxes will work well, and you always get bright solder joints. So this is a product we're really quite thrilled about. For vacuum vapor degreasing, this is what we're working with right now. It really opens up what can be done. You don't have to worry about flammability with the vacuum degreasers, so you can use hydrocarbon solvents, really mash the solvent to the soils. The challenging part with a vacuum degreaser, there's no free lunch, so they're much more expensive to much higher capital investment, but be lower cost in terms of the chemistries used within. So you see there hydrocarbon solvents, alcohols, modified alcohols, which as a chemist I'd call glycol ethers, ketones, and even vacuum degreasers aren't intended to release the solvents to the atmosphere. Everything is really self-contained. However, we need offer zero VOC components. So we're finalizing development on these products, and if you have an opportunity, you have a stubborn flux to get rid of, let us know. Let's talk. Or you want to keep your vacuum degreaser, we can go from there. So let us know what you have. You can skip this. Skip this one. It's kind of redundant slide. Thank you. We talked about the toxic 4. Saroj mentioned these. Want to include this slide because if any of you are using these toxic components, you'll see that these are the dates that they got to be gone. Now it's a little more complicated than that. There's phase outs, there's can't produce, there's can't use, there's some industries can and can't, but it's a complicated map. But nevertheless, if you're going to take the effort to switch, you don't need to switch to these. And if you're using them now, let us know. We're happy to give you a better alternative. So let's see, keep moving. You can keep moving from there too. Challenges with other PFAS solvents, compatibility, odor, flammability. These are all things we really have to deal with. We're kind of preserve some of our time for some Q&A, so let's move on to the next one and hit that real quick. Again, kind of saying things we've already talked about, so I won't spend too much time on this. It's always that you give yourself more latitude with lower global warming and lower environmental impact. For both, public acceptance and regulatory acceptance. So we can move on. Yeah, this kind of covers some of the things we've already covered before. So a little more of the trade-offs involved. So again, like I said, we offer really a full offering of cleaning to replace the Novec products from chemically identical to functional equivalent, molecular identical to functional practical equivalents to PFAS-free next generation, or even for the higher capital levels that you want to get into, water and vacuum degreasing as well.
Thank you, Paul. Yeah, that's a lot of chemistry lessons today. Let me see if I have anything on questions from. So Ed Forrest has a question. Products like 3710, 3730, or 3900 available as hand cleaning, aerosol, or pen?
Yeah, they are. I mean, not directly, but I mean, I don't know if I mentioned it, I meant to. Um, the Novec used to offer a line of aerosol products for for hand cleaning. We've had ITW, Chemtronics, and Techspray are aerosol companies, so we've had functional equivalents for many years. However, some people don't want to go through the qualification process. Given a large enough opportunity, we can copy the Novex as well, but it becomes it becomes a kind of an expensive proposition with a high minimum order quantity if you really want to get a Novec replacement. So it's best to take one of our legacy products that are branded either Chemtronics or or Techspray. For convenience packaging in the pen, we do have a pen. Thanks for asking, Ed. I know you're very familiar with that we offer in our fiber optic line. And this is a fluorinated compound. It's great for working in areas where you need to clean a fiber optic interface or do a little bit of spot cleaning, but you don't want something flammable. Some really maybe super critical environment where the risk of flammability, or even if it's not a high risk, if it's a high consequence of flammability, is there. If you need to clean an interface in a data center, there it is. And it's also very fast drying. We have water-based that'll do the same thing, but water takes a while to dry. This will dry like that, and you need a clean fiber optic interface.
The next question is, have you tried running testing on cryotex removal or other PFPs?
Did you say Crytox?
Yeah.
Oh yeah, sure. Yeah, we've done projects for customers. Again, we're trying to replace the Crytox on a part. They'll send us a part contaminated with Crytox, and most of our fluorinated compounds will remove it. The more highly fluorinated it is, the easier to remove. And we're using that now. Like I said, those ultra clean solvents. One of the biggest things they're good for is for depositing either coatings or lubricants or adhesives, because they're left behind on the surface and allowed to dry. So anything that's contaminated in the solvent dries onto the part. And for some of those things, like a semiconductor or magnetic media or something, has to be super clean. Because you don't want to deposit anything. You only want to deposit what you want to deposit. So carrier solvents and so on are good for that. And again, that's kind of matching the contamination with the solvent. A lot of those solvents I described as gentle and weak are actually great for Crytox because their chemistry matches the Crytox, and will remove it right away. So it's a very highly fluorinated product, PFPE lubricant. And even some other fluorinated compounds we can remove very easily with those. Happy to do it. Different grades. Happy to if you want to send us those grades or tell us what they are, we'll do a project and get it back out to you within a short period of time.
Yes, and that's the wonderful thing about sending stuff to our lab is that they just not gonna recommend only one option, but if something doesn't work, they'll have like a full list of product they have been they're gonna used or can be used in replacement. So and they create a lab report. So yeah, happy to assist any kind of development process or testing process with you guys. The next question is, does PFAS-free solvent that does not contain fluorine and element in the new molecule?
Pardon me?
Does PFAS-free solvent that does not contain fluorine element in the new molecule? I think they're asking about the new chemistry which we have launched, like 3900, if I'm correct with that question. Maybe whoever wrote this, they can ask me again. So what I understood is these new PFAS-free solvent, does they contain a fluorine element in them?
Yes.
Yes.
I mean, yeah. I mean, the it's PFAS-free by the EPA TSCA definition.
Correct.
Unfortunately, non-flammable and non-water, something fluorinated, it either doesn't exist or is highly toxic. So those toxic four we mentioned, the the brominated and the chlorinated compounds.
Mhm.
Great cleaners, non-flammable, toxic, carcinogenic. So to have something that's safe, that you would want to spray as an aerosol, you're really stuck with a non-PFAS fluorinated compound. I look at the periodic chart and there's a spot right above fluorine. If there was a compound there or atom there, then we could do it, but it just doesn't exist. Not in this universe.
Thank you, Paul. The next question is, and I can answer this. Do you have a list of or spreadsheet of 3M discontinued product cross to Techspray product? Yes, we do. And I'll be happy to reach out after this webinar to provide that. And also, it's actually listed on our Techspray website. If you go under our product section on the main page, it'll say the Novec replacement and the options related to that. So if you're not able to find it, I'll happy to assist you later on. Thank you. So I think we have answered so far every questions which came through the chat. If anyone wants to reach out after the webinar, please feel free to contact me or Paul. You have our contact listed on the slides, and we will be happy to assist anything either product related questions or regulations related question. We do have a regulatory person who is helping us to keep us eye on what's going on with the EPA or even outside of US area. So happy to assist any kind of product development or any regulatory questions you may have after the seminar. Thanks for your attendance, and we'll look forward to attend next time. Thank you. Thanks, Paul.
Thank you. I know.